Today we have our presentation on the data holders perspective from the Charité Data Integration Center, and our guest is today Fabian Prasser. And first he will give us a short introduction into the topic, and then as always you're welcome to give us your questions and everything in the chat, or you can just ask the question yourself. We also will audio record this meeting. So yeah, just that you know. Okay, Fabian, then you can just start.
Yes, and now Uli is there as well. So you can now see my screen?
Yep.
Oops, in theory. Now you can, right?
Yeah, thank you. Apologies. We had some examination emergency we had to fix. So I'm happy that I'm here already, but I'm quiet now and come back in about 10 minutes with questions.
Okay, great. So everybody, hello and welcome. Feel free to interrupt me at any time, Uli, or the audience. I have quite a lengthy presentation prepared, but was just informed that this is supposed to be more like a podcast style interview of me. So I'm very happy to do this in any way that it works for you. I will just give my presentation, and maybe I'll stop at certain points and say that this is now maybe a good point to ask some questions. Or you can also, as mentioned, just interrupt me at any time. And what I'll be talking about today a bit is basically a data holder's perspective on secure processing environments and how we at the Charité Data Integration Center implement secure processing environments, where we currently stand, what types of services we offer, and also a bit of a perspective, if we come to this point, into what we're planning to do in the future. So I would like to start by an overview of our data infrastructure that basically together forms a secure environment for processing data internally, as well as also provide external access to researchers that are interested in working with Charité data. And for those of you who work in the field, this figure might look quite familiar. These are, let's say, quite common building blocks of health data infrastructures. And we have the Data Integration Center as the overall organizational unit in charge of running our data platform, which is shown here in the middle. But we do have some, let's say, flanking major blocks of our architecture that provide additional functionality that is important for secure health data processing. One is the data trustee unit, which provides services for prospective interactions with patients, as well as data pseudonymization and data linkage. And the other one is the data governance unit, so an organizational unit also with technical solutions for controlling basically what types of research projects can be done with the data and under which conditions. And together, those different building blocks provide a variety of functionalities to our local research ecosystem and beyond. A couple of them are already mentioned: data pseudonymization and linkage. Consenting is an important part. Applications for data usage, but also very important mechanisms that allow our researchers to find data that is relevant for studies to be performed, and also tools that support prospective finding of patients and prospective study processes. And last not least, we're of course connected to a range of national and also international data networks and platforms. I mentioned the network of University Medicine and even Odyssey here as examples. But generally speaking, we are working more and more towards opening up this infrastructure also for external access. And I would now like to use the remaining time as far as we can get to sort of walk you through the different building blocks. And I will start here at the center with our basic underlying infrastructure, which is the data platform. And the data platform, obviously, at its very base, is also a quite technical platform, which I would like to quickly comment on. We are traditionally a Cloudera customer, so we run a Cloudera data platform, but we are in the process, and this is quite far advanced, of migrating our platform away from Cloudera to Stackable, which is a Kubernetes-based data processing platform that is basically multi-cloud ready. It runs on premises, but it's prepared to be moved to, for example, a sovereign European cloud infrastructure should Charité decide to go this step. And in regards to the data processing components that run on top of our Kubernetes cluster, this is the usual, mostly Apache-based software stack comprising NiFi, Kafka for stream processing, Spark and related technologies for data processing and for the creation of data products. And this is all basically open source and based on open APIs with baked-in data governance, security, and so forth. It has an SQL query engine. It's now Trino-based and Stackable, HDFS type data storage, which is now S3 and S3 object storage in Stackable, and of course allows various types of platform operation functionalities, currently mostly based on the Stackable operators as a result of this migration process that we are going through. And based on this sort of underlying technical structure, we have established quite, I would say, comprehensive data processing platform, which you can see here in an overview. It's a usual data lakehouse architecture where we are connected to a range of the various routine, particularly, but also research information systems at Charité. And this data is then ingested. It goes through 3 different layers, basically, of data processing, right? So bronze, silver, or gold. We call it raw, prepared, and interpreted, where the data is pseudonymized, quality controlled, and in the end, finally standardized. We are putting a lot of our focus basically on creating standardized data representations, so the FHIR National Core data set, but also the OMOP-COM data model, which are increasingly also linked to each other. So we aim to mostly generate our OMOP-COM data model representation out of our quite large FHIR clinical data repository. And in addition to this, we have sort of intra-institutional data assets and data products for various parts of our data landscape that are, for example, not yet standardized, or where there are quite specific requirements by users of our platform for processing them. This mostly focuses on low volume data, or structured information, but also, for example, textual data. But there's also the opportunity or the possibility to pull in raw data assets or high value volume data on demand. So, for example, the platform is connected to our PACS systems for all types of medical imaging, but we can also ingest ECGs. We have live data streams from all monitoring systems at Charité into the platform. And this is not reflected directly here, obviously, within the standardized representations, but can be pulled in on demand for individual cohorts that are being analyzed, for example, in a retrospective study. So usually users of our platform, right, we are here to talk about secure processing environments, do not directly interact with these core parts of the platform, but that's a high security perimeter within our infrastructure that a dedicated team works on. But what we do have for our researchers is basically different types of services that are shown here, that are centered around this idea of secure processing. And also here, there's different layers of services that are provided that are increasingly technical or less technical, with the more technical tools being shown here in this left side or the middle part of the slide, that are basically for data scientists that are able to program, for example, in Python, or researchers or representatives of various departments that have data stewardship roles, so that help us with quality controlling and standardizing data, but also, for example, a data delivery team that helps to prepare individual data representations, for example, for further analysis within the platform. And also building on this, basically, there's also our so-called platform self-services. So this is applications that are oriented more towards simplicity of use or towards use by researchers that are, for example, not familiar with common data science technologies, that more require something like point-and-click interfaces to work with the data. So let us dive a little bit deeper into those technical solutions. They basically form the core of our secure digital workspaces that are directly provided within the platform. You can see here that data comes directly. There's quite some noise. Maybe somebody would need to turn off his or her microphone. Thanks. That data that comes directly from our data representations, and then within the platforms, or within the platform, users can create notebooks, for example, where data is made accessible. So we have the internal data delivery team that prepares data for analysis by researchers, and then they can create notebooks. Within those notebooks, they can basically point towards the data assets that have been generated for them, and then, for example, work with the data in Python or also in SQL and create dashboards. In this case, this is an example of a dashboard created with Apache Superset, which also has an included SQL Lab component where people can run queries over the databases, catalogs, and schemas within those databases, and that they have access to. So this already sort of provides a core secure processing environment, and it's a very good point for Uli to ask me a question.
Exactly. So this is amazing. If you go one slide back, I think this is a beautiful blueprint of what you could do. My question would be, as we introduced earlier, the 5 safes, which actually you initially brought into NFTF Health, would be, how would I apply for a project of using this infrastructure, and how would you check the people if they are safe? Which education do people need, or do they need a BIH Charité badge that suffices in order to go into there?
Yes, very good question. So I do have a slide later on the technical application for applying for access. We have a specific application portal, a project application portal that we have developed and operate together with our biobank, where researchers can apply for access to data for retrospective studies. There might also always be potential other reasons for why people would like to analyze data, for example, for quality assurance processes, but let's focus on the medical research part. In this case, so currently to this infrastructure, we only provide access to our internal researchers, right? So they need to have a Charité affiliation, and this means that they have underwent basic information security and data protection education as parts of our regular training programs. And then they need to apply for let's assume a classical retrospective study for access to the data. In order to be able to access, to submit this application or get the application approved, they need to provide an ethics committee application and a positive ethics vote, as well as a proof of coordination with our data protection officers. So we have our clinical trial office, which is in charge of handling clinical studies from the data protection perspective at Charité. So this basically gives you the safe people, and it gives you the safe projects, right?
Okay, but I see something beautiful here, which I was missing for other SPEs, because you get something for free already, right? You would see some pre-analysis on the left side, at least how I understand it, and you would get a data catalog where you could already look what's available. I think that's very important functionality from the user side, because otherwise you look in a black box and tell, then you're being asked, what do you need? And I think, I would take everything, and then we cannot give you everything. And think for this dialogue, this is really important to have some data catalog, plus what I see above, some notion if those items are filled, if there's some data in there. Data catalog is good, but it's more important to know, is there something in there I could need for some, for some feasibility study, for example?
Yes, exactly. So I can jump into this in a second and tell you a bit more, because I have explicit slides prepared for exactly this. Maybe just to finalize the 5 safes and perspective on this, right? So we have safe people, we have safe projects, we have safe data, and that all data that goes into the platform undergoes a pseudonymization process. we potentially implement further privacy controls if needed as part of the basically data provisioning process here, the data delivery process into the project-specific workbenches. And then the safe environment, of course, is provided, or the safe setting is provided by the secure processing environment in itself. And for assuring the safeness of outputs, that's under the responsibility of the researchers. So currently, we do not do output checking, but require researchers to take care of making sure that there's no privacy risk associated with the output that is being generated. Maybe to come back to your nice comment on our how do you say, our findability solutions. I can jump to this for a second because that's exactly here on the slide here. If we take a look at this feasibility and data analytics as well as project applications part. So what we offer here is the Charité Cohort Finder. It's a platform that is available for all researchers at Charité. So this is as all the other services, it's connected to our central Active Directory. So all researchers with accounts are generally able to log into those systems using basically a single sign-on procedure. They need to be registered, or they need to be, how to say, like approved for access. So usually you have a registration part. This is here a button that you can click on and you say, hey, I'm a researcher, I'm interested in getting access to the system. And then this is a system where all researchers can independently and basically without requiring programming efforts, programming skills, without us as the operators of the data platform requiring to perform any type of human-in-the-loop services, do some basic searches and also some basic descriptive analyses of our anonymized data that we provide through the platform. It's currently not all data that is reflected in our data discovery service, but basically a significant fraction of the data that has been standardized. So it's sort of the gold level of the tip of the pyramid of standardized data that is being made accessible here. And here researchers can go and can see what variables are available, how large cohorts are of patients with certain characteristics that they are interested in studying, and then use the results of this search process also as input into their data access applications, right? So when they go, and I'll come to this in a second, to our data access portal, they can provide this information, which helps us then basically to check and also deliver the data that is needed.
Then the question, we learned before from other talks that there's two ways to provide an SPE. One would be that you check in a data set once and everybody who gets granted access sees the same data set. So that's what you could do with data releases, which are fixed, like updates only half a year. Here it's different, right? Somebody checks the data and selects a subset, and I think with the cohort finder this could be quite precise because people already see that this variable is populated, the other not, so, and they compose. And then is the data already in the SPE, or does it have to be transferred then from the selection process into the SPE?
Yeah, this depends a bit on where you draw the boundary of the SPE, right? I mean, calling this whole thing a complete SPE depends a bit. There's various different definitions of what an SPE actually is. In our specific case, it's a larger data platform that provides secure access. Yeah? And now it depends a bit on what you consider to be part of this large platform, right? If you consider all this to be the platform, then the data is already in there. If you say the secure processing part is what is user-facing, then the data basically needs to be, in quotation marks, moved over. It isn't really moved. It's not moved between servers, but the data is extracted and stored in, let's say, separate tables, for example, in a separate data asset, in a separate data product for access by the researchers.
I think that's our hypothesis, that what you see here is overall the trusted research environment, including user authentication and everything. And in the sense of the EHDS, actually that's how I read the law. Secure processing is more narrow, containing storage and computing and the data itself. So it was until now a very good hypothesis.
I mean, of course, we also offer storage and compute capacities. Maybe this also just as a side note, right? We have the compute cluster, which provides compute capabilities, but we also operate separate high-performance computing clusters at Charité. So in specific cases where researchers require high-performance computing, the data is actually moved into the high-performance computing cluster for further processing. There's some computing offered here, but if there's a particularly demanding analysis to be performed, then the data can also be moved out of this secure platform into another secure platform that is specifically designed for example, batch processing. Yeah. So coming back maybe a second to the cohort finder, right? So you can basically define inclusion, exclusion criteria, create cohorts, run basic analysis here. This is comes in very handy for project applications, but of course also for other types of, let's say, frequent requirements that researchers have at an academic medical center like Charité. For example, if they're preparing third-party funding applications or they're planning studies, they're not directly at this point in time interested in accessing a data set, but it's still, of course, an important functionality that they can find out how large cohorts are, for example, how many patients we see over time and with certain characteristics. What they can also do here, and this goes a bit deeper into the data catalog, is that they are provided with an overview of, let's say, the most important types of data that are available through the platforms, so through this integrated data catalogs, where you can see the different data types and roughly how many data points or instances of these data types we have available. You can also, this is obviously just a screenshot, but it's possible to click here on the individual data types, and then you get a pop-up that tells you a bit more about, for example, which terminologies and ontologies have been or are supported in the platforms for representing this type of information, what fraction of the data is standardized, for example. Just taking the lab values as an example, we don't have all lab values mapped to law codes yet, but just a subset, so there's a bit more information provided. And within the data catalog, and it goes even deeper, you can then click on a link. That's unfortunately, I don't have a screenshot here on the slide, and directly jump to the technical data specification within the platform that then goes a bit deeper into how specifically the data looks like. What's maybe also interesting, or what I find particularly handy, is that through the integration of terminologies like LOINC, SNOMED, ATC, you get hierarchical structuring of the data, right? And this is very helpful, for example, here for, it's unfortunately not visible here, but for creating a hierarchical organization of the different data elements that helps people a lot with finding variables to query for. But you could also do stuff like plotting this way how frequent or how many measurements you have, for example, and for different types of laboratory values. And coming back to this findability aspect, and then going to, maybe I can talk, I have a few more slides on this. This is from one of our papers. That's a sort of a feature of our platform that we also have to study how frequently it is or how it is being used by users, right? Like which variables are they particularly interested in, how often the system is used, at which points in time, and quite interesting, how complicated the queries are that users can perform. As I said, this is from a paper. We have different instances of this data discovery platform. This is a specific instance for a study, which is separated from this larger data discovery platform for the data that is available through the SPE. And what you can see here is that most queries that users run are actually quite simple. For example, with concept touch, you see the number of variables that the query uses. So quite often you have one combinations of one or two characteristics that researchers are interested in. The use of more complicated temporal query features means what you can do within this data discovery platform is you can also formulate temporal conditions, right? You say, I'm interested in patients which first have event 1, and then at least 5 years later have event 2 recorded or so. This is a feature that is not used that often. This also reflects in query, reflects basically in query complexity scores. So we have some like scoring mechanisms that determine the complexity of queries. And you can see here that usually what people use the platform for, or what researchers are interested in, is rather simple combinations of inclusion and exclusion criteria to select certain cohorts. So now that researchers have found a cohort, they can request access. Yeah, so that's this accessibility and reusability part that I mapped this through, and this can be done through our project application portal. It's a digital portal with the usual functionality, what you would expect, right? You can go there, and as I said, considering that you already have all requirements, which means positive ethic votes, just to repeat this, and proof of coordination with the data protection office that is in charge of handling studies at Charité. You can go in there into the portal, you can log in, you can describe a bit your study, you can attach those proofs, and then you can request access. And there's different access procedures that can then sort of be triggered depending on what specifically is being requested. The portal is also in use for external applications, currently particularly those that reach us through the structures of the Network of University Medicine and the Medical Informatics Initiative. And in this case, this triggers a decision to be made by our Use and Access Committee that has been established for this. And access decisions by the Use and Access Committee would also be triggered, and we are seeing this increasingly more now finally for projects that request access to data based on the broad consent that patients have signed. And then directly within the portal, the committee can also make these decisions, right? So we have the committees registered in the platform, and then they can discuss project proposals and vote in favor of a project or against a project, and we have opportunities to request corrections or additional information to be provided. And this is all possible through the platform, while it at the same time transparently provides users with basically information on the status of their request, so that this is sort of like all being provided in one place. And the platform does not exist in isolation, right? So you can attach, we're working on integrating this all more deeply with each other. And currently you can attach, for example, the cohort, so you can do the cohort selection, the cohort finder, and attach this information here. You cannot directly jump into the project application portal, for example, unfortunately at the moment. But what the project application portal is integrated with is the National Research Data Portal for Health. So we have API access and can ingest project applications from the national portal. And at the same time, the project application portal is connected to our internal project management platform. So all project requests that are being submitted and then approved are automatically registered in our project management platform that our data engineers use for fulfilling basically data access requests, right? So when they work on what do you say, like extracting the data and providing a separate asset for people to be used. And we manage this through GitLab, and GitLab is also accessible by all our researchers. This is not an ideal solution because GitLab is quite a technical platform, so it requires our researchers, if we, for example, have additional questions that we need to ask, if we need to go through revisions as part of the data provisioning process, then this is managed through GitLab to a certain degree, which is not ideal for, let's say, the average researcher, but it works well enough and is integrated here, as I said, with the project application portal, so the information directly goes there and is synchronized into the system and without additional steps being required.
The question could be, can you link different data sets here? I like the integration in the MRI portal on the left-hand side. So you see the different processes. I think that's quite difficult, right? Because if you have some outside data and you want to link it to some internal data, or maybe I misunderstood it. So people are asking from outside for Charité internal data via the portal, right? Yeah.
Exactly. Yeah. I mean, it's a data use project application. I don't know which parts of what is being. So this is relatively new that we have this interface. think
Very
it's
cool.
also still
Yes.
in the pilot phase, and I don't know what specifically the FTPG API delivers, as part of this information. But it is implemented and it works. Has been
Nice.
successfully.
So the most pressing question now would be, how can the user see the data? Because we saw some very sobering stuff with command line. Then people told, well, they have to learn Linux if they want to see our data. So I think it might be easier with the RStudio or Python. So that would be the next step. And the step afterwards, immediately, who checks what people are taking out of this secure processing environment? Because I think that's a crucial part which could bind a lot of stuff.
Yeah, so maybe first talking about how can users see the data. Let me go back a couple of slides. As I mentioned, we do offer notebook systems, right? So you can have a Jupyter notebook, you can spin up Visual Studio Code, you can have RStudio, a notebook to work with the data. That's the standard mechanism that is provided as part of the secure digital workspaces, potentially also, as mentioned, running SQL queries here over the data or creating a dashboard. So that's the standard tools that I'm aware of that the platform offers at the moment for seeing the data when you work with it retrospectively. Seeing the data is also something that we do provide under certain conditions, actually prospectively, and maybe I can quickly cover this because it's somewhat special. We also have prospective study support that we offer as part of the platform through our FHIR-based research electronic health record. So we basically, the data that has been standardized within the platform is being presented to users as a pseudonymized electronic health record with access control mechanisms. So here, researchers at Charité cannot easily go into the system and search through the data, but they can be, they can be allowed to access data for certain cohorts. And one common way or one common functionality where this is used for is for prospective study screening, study pre-screening, where we can define inclusion-exclusion criteria, somewhat comparable to what we've seen with the Charité Cohort Finder. And then we generate screening lists that people can use to screen for potential study participants. And this can also be done in a comparable way for running prospective trials. So when researchers include individuals into prospective trials, in this specific case now, trials that use an extension module of the broad consent, and then we can display basically study patient lists where the researchers see which patients they have included into the study. And it's important to keep in the back of your head that sort of the study context here provides the access control mechanism. Because there's more, as I said, it's an electronic health record basically, so you can jump into the record of the patient and see what information we have for this patient, but only within the subset of the records that are either part of the cohort that you're pre-screening for a study for, or that you have actively already included in a study in a prospective setting. So this gives you an access control mechanism for this pseudonymized health record. And before you ask your next question, I will comment on output checking. As I already said before, we currently do not check outputs that researchers generate within our platform. It's the duty of the researcher to make sure that, for example, statistical results that have been created are not identifying or contain any sensitive personal information.
Okay, great. Let's see the output question. So we're already proceeding in time. So the question would be about metadata. So I look in the chat, there's quiet, so please use the chance and ask Fabian some questions. So you told about metadata, on FHIR, on OMOP, interoperability is given there. So we've been talking to French cohort, to the fresh people, maybe somebody's even dialed in. And recently they told that they're concentrating more and more on Health Decade AP on registering their data sets. It's something different, of course, because it's epidemiological cohorts. Here we're talking about healthcare data. But I think there are quite some similarities on thinking, because this is amazing if you can look at the trajectory of patients, combine all the data. Same could be true for the venue of a patient within a clinical trial or within a cohort, so you can have this virtual record. So what do you think, your opinion? So FHIR OMOP is good, terminologies is really good, so what additional efforts should be taken in order to be pluggable more or less to the European health data space? That's something we all have to do within the next 2 years, right?
Yes, a very good question. So I would say, I would argue, in my understanding, what Health DCAT AP does and what, for example, OMOP and FHIR with associated terminologies and ontologies do is a bit on a different level, right? Health DCAT AP, as I know it, mostly describes a data set on a bit more higher level of abstraction, which is very important and which we also have on our radar and have also been studying already. So it's definitely something that is part of the further development of our data catalog. We plan to include that we have higher level descriptions also of the different data sets and data sources that we provide access to through the platform. Also, generally speaking, I think it's also so something that is very important that we have been working on a bit, but which is quite challenging, is that that you sort of that we bring more and more of the data, for example, from clinical studies or clinical registries that are run at Charité onto the platform and make their existence transparent there, potentially also provide an integrated access mechanism to these types of data. We have been doing this for a couple of selected studies, but it's not yet a standard procedure. And that's a bit unfortunate, as we, for example, also have a lot of the clinical research or systems from the research domain connected to the platform. So, for example, Charité is a very heavy REDCap user, and REDCap is one of the systems that is connected to the platform. So we could relatively easily, at least generally, make available the information on the different types of REDCap projects that we have and complement this, for example, with metadata that is documented through Health DCAT AP. Of course, we also do have a study registry or trial registry where information could come from that is being added to the platform on this level. So long answer combined into a short summary. We have this on our radar, but it's not something that we already have implemented. And it's quite challenging, in my opinion. Maybe with the tools that we are traditionally used to working with. It might be something that could potentially benefit a lot from AI support, for example, that we generate this more higher level descriptions of data that we have.
I agree. There's a live question directly to this or another topic?
Yeah. So exactly. I mean, thank you. Very interesting. So I have a question regarding, because you do have different sources where you get your data from, right? So how does it work when it comes to really integrating these sources? Because I assume that the underlying architecture and technology that they use is quite different. And when it comes to your pseudonymization service, for example, do you provide, like, is it like provided as a service to these sources? And do you also have to provide support to these institutes to put in the data when it comes to pushing it to the platform?
Yeah. So thanks. That's a very great question. So I have one slide on this here, the interoperability slide. And we do have a wide range of systems connected to the platform. But this is, of course, also something that is quite tough, as Charité has hundreds of different IT systems that are generally relevant for being connected to the platform. And what you can see here on the slide is a selection of, let's say, the biggest 7, 14, like 15 or so systems that we have connected, right? So that's our EHR system, the radiology information system, the picture archiving communication systems, ICU system, emergency care system, the document archive, the connection to all our monitoring systems, ECGs, REDCap, for example, and SecuTrial for clinical studies, and also our biobank information system. And this is something that is being done by the core platform team, right? So usually it's not somebody that maintains such a system that connects it to the platform, but it's a job of the core platform team that operates this whole thing to get the system connected. We do usually need support by people that are well aware of the clinical information or research information system, that, for example, administer the system as part of their daily work. And because, as you said, those systems are extremely heterogeneous, right? They use very different types of data representations, very different database schemas, very different terminologies and codes. They very often lack documentation. It's quite intransparent how specifically the databases look. So that's actually one part of our work where most of our effort goes into, is into connecting those systems, understanding the data that's in the system, and then going through this bronze, silver, gold level process of standardizing the data and bringing it into a form where it's quality controlled and, let's say, readily available for research use.
Great question would be how many people are in your team? So the core team, I know, was in the Medical Informatics Initiative. So that was the data integration centers. I think this is much more what we see here.
So the team size is roughly 20 people that operates the whole thing.
20 well-educated and motivated people, right?
Exactly, of course. There's a couple of adjacent teams that contribute to this. Overall, it's maybe 25 or 30, but the core platform team that is in charge of most of this.
This is huge. I asked this because we, in the audience, we have some people who are preparing, for example, for the German Centers for Diseases. So DCGs are preparing for that as well. Of course, they do not have 20 people taking care of it. They are very motivated. Maybe they can do it with less people, but we have to do some sizing there. The data sources are easier. For example, it could be REDCap and clinical trial data are being combined. But I think the way would be pretty much the same. You have to look at the data sources, look how you can link it, how you can clean it. That would be 80% of the time. And how you could make it findable. So this data catalog is of utmost importance. And next month, we see the data catalog of the DZD, and we get some information how much effort it is actually to create this data catalog. And here we saw nicely how important this data catalog is for findability, and combined with the information that their data is there for those data elements. I think this is key for all the following processes. Yeah.
And to answer the second part of the question, pseudonymization services. So this is sort of the pseudonymization process is part of the process of connecting a system. Pseudonymization requires us, of course, to very well understand what data we are seeing, right? And to make sure that we, for example, mask out identifying information from the data that is being ingested. So this is really done on a project, or not project, but on a system by system basis. We are going through the system, we are developing the connection, and we are customizing basically the pseudonymization process. This brings me to another slide that I have, and that's on our data trustee services that provide the usual functionalities, right? Supporting studies in registering patients, collecting consent, but of course also pseudonymizing data. And that's something where we have been working on a lot in a dedicated project called THS Med, or the TrustX services, because we realize that there's currently hard to establish a pseudonymization procedure as a dedicated service at an institution that can serve multiple different purposes in a way that is really highly scalable. Yeah? And so this is a bit of an advertisement on something that we've been working on for a long time. There's also a link here that brings you to a website that we have. And here the idea is basically to have a high-performance pseudonymization service that can really, for example, be used to process all data in our entire, or not all data, but all, for example, primary identifiers that we have in our platform, which is, I don't know, considering patients and cases, for example, would be around 20 million identifiers. But there's many more identifiers for documents, for imaging studies, and so forth. So we're really aiming here to create a system that can handle these types of workloads. It's quite scalable. There's also a paper that we published on how this works and how fast it is. Currently, we can process around 6,000 identities per second through the system, and this is what we are in the process of connecting our platform to. Currently, the pseudonymization that we do is a platform-owned service, basically, that uses cryptographic primitives, but we would be interested in moving this out to a dedicated service unit.
Okay,
And
we have to prepare for the last round of questions. So
Yes.
I think this is amazing. Maybe somebody should post this paper. This is very important. Müller et al. And Jamir. And Api, do you get a question directly to that? Or
I just have a follow-up question, but again, I see one question being raised in the chat, so I mean, I'm fine.
that comes up. So the question in the chat was very interesting. So how long did it take to plan, to recruit, to set this up, all the privacy, Betriebskonzept, all the stuff?
Yes.
So
this is a 10-year effort, right? So this has started in 2015, 2016 with the sort of start of institutions working on the medical informatics initiative. It has been revised once significantly, the whole architecture as part of this process. I'm now at Charité for 7 years. I'm basically in charge of a lot of what you have been seeing today since around 6 years. But overall speaking, I think from first ideas to where we are currently, this is a 10-year effort.
Okay, and there's some cheers in the chat right now because first people have to leave. So is there one slide you want to show urgently?
Yes.
Otherwise you cannot sleep. I bet, yeah.
I would like just maybe to wrap this up. I would like to make one final point, right? I've been focusing now a lot on the infrastructure that we have internally for the Charité research ecosystem. We do provide some services for external access through the MRI, but also through federated studies, for example, in Eden and Odyssey. But obviously, a secure processing environment that sort of brings or fulfills this vision of allowing external researchers rather direct access to the data that an institution like Charité has needs to be even more secure than the platform that I presented today. And this is also something that we are actively working on. I would like to reference the Medicore project here, which is one of the core initiatives by BIH at Charité, where we basically work on setting up a large-scale secure processing environment that is then supposed to provide more direct access for external researchers, also to be more of an environment where you can also bring your own data, right? So the environment that I presented is an environment for providing access to the data that we have prepared in the platform. And there's also a lot going on here in the Medicore project. I would like to point again towards Chorus, which I think has also already been presented here as part of the series where we have quite a close collaboration, and which is one of the solutions that we are working on. We also have a project, for example, where we work with the Iridia DRE. This is more focused on data from clinical studies. Also actually quite a nice product by a Scottish company, I think. And then we also have a lot of activities in the federation field, right? So federated data processing, parts of it can also be either considered providing a secure processing environment or be an important functionality for secure processing environments to be able to federate across different environments. And so this aspect of opening this even more to the external world is something where a lot of work is going into from our side at the moment.